Merhabalar herkese. Bugünkü webinarımıza hoş geldiniz. Ben Ekin Akın Korkut. BİAS Mühendislik'te lisanslama ve eğitim uzmanı olarak görev almaktayım. BİAS Mühendislik, makine mühendisliği disiplinleri çerçevesinde ileri mühendislik çözümleri sunan bir firma olup Ar-Ge, CIA yazılımları, test-ölçüm sistemleri satışı, proje-analiz ve test-ölçüm hizmetleri ana çalışma alanlarıdır. Detaylı bilgi almak için web sitemizi ziyaret edebilir ya da tüm sorularınızı info@bias.com.tr adresine iletebilirsiniz. Webinar dili İngilizce olacaktır. Webinar esnasında ileteceğiniz tüm soruları chat üzerinden yazabilirsiniz. Sunuma başlamadan önce webinar hakkında kısa bir bilgi aktarmak için BİAS Mühendislik'ten Umutcan Bey söz alacaktır. Buyurun Umutcan Bey.
Teşekkürler Ekin Hanım. Merhabalar herkese. İsmim Umutcan Salman. BİAS Mühendislik'te CA takım lideri olarak çalışıyorum. Webinar dili İngilizce olacağı için webinar öncesinde Nina Hanım'a sözü bırakmadan önce kısa bir İngilizce giriş gerçekleştireceğim. Now, hello everyone. My name is Umutcan Salman and I work as the CA team leader at BİAS Mühendislik. Before we begin today's webinar, I would like to share some brief information about this webinar. The webinar will focus on how to P7 platform enables collaborative solution for multidisciplinary application, allowing the teams to work on same page, and how design time can be reduced through process automation. P7 is a French software company specialized in optimization and machine learning algorithms. The company now focuses more on low-code automation solutions and collaborative environments for engineering application. Today, the presentation will be delivered by Nina Moella from P7. She works with the title of the application engineer with a background in aerospace engineering and experience in research. Nina is an expert in P7 products. The webinar will be held in English. You may submit your question in the chat section during the presentation. Now, with your permission, I would like to hand it over to Nina. Hi, Nina. Could you
Hello.
hear me?
Yes. Do you hear me well?
Okay. You can start as you wanted.
Great. Thank you, Umut, for the introduction. Thank you, Ekin. Hello, everyone. So I would like first to thank BS team for organizing this webinar. So my name is Nina, as Umut introduced me. I'm an application engineer working for a P7 company. So I'm working from France and very pleased to be here with you today. I will start sharing my screen and explaining to you this topic of today. Here we go. So our main focus for today is this car suspension analysis in P7 Enterprise. P7 company has various products to offer, but the one we will focus on today is P7 Enterprise, which is a cloud-based solution for more collaborative engineering. So I will introduce that. First, to introduce the company. So P7 is a software editor founded in 2010. Focused on optimization and machine learning algorithms for engineering applications. But since 2015, now we are totally independent, and our main focus has now changed to a more collaborative engineering and low-code automation platform. We have employees worldwide, but the headquarters is in Toulouse, in France, where I am located. And thanks to the mathematical roots, we can apply the software to many different domains. So we have a large customer base on different applications, going from the aerospace industry thanks to our Airbus roots, but also now moving more into the automotive and energy sectors. As BİAS is, we have worldwide sales through a very powerful network of resellers, for the moment focused on the Asian part and the European one, and also moving now to the US as well. Through our project, we experienced some struggles in the engineering world, and I want to explain our findings today and also why I am here. So the first engineering struggle with simulation today that we found is the fact that those engineering teams, they have a lot of fragmented workflows. You may be part of such a big company where you need to provide very precise and very advanced products like automotive or aircraft can be. And in order to design such projects, you need to rely on a large variety of different tools, including CAD, CAE tools, but also some scripting, some post-processors, some in-house even tools. So you may find some coordination difficulties in sending your simulation from one tool to another. So going from one CAD to the mesher, then to the CAE, post-processor, scripting, sharing potentially with colleagues. So in all that domain, you have fragmented workflows in that sense with, for example, different data types, data formats that you need to check regularly. All those checks, they also rely on manual data management. So for that, we need engineers for the moment to check that all the data, all the files are well produced, that there is no mistake. But of course, we are all human. So first, this takes a lot of time. And we also lose a lot of time by doing that. And the other part is that we may still make some mistakes. Okay, you may have not the updated files, or you may have lost some data, or just misunderstood something. So in the end, it's a lot of time that is wasted. Plus, this is not an added value for the company, because you're just doing some repetitive tasks and you do not produce what you are here for. So you're not even doing simulation or let's say tuning simulations, you're just preparing something. So here is the second struggle. The third one is the lack of collaboration and those knowledge silos that we can see between teams, for example. So we know that to build a car, for example, we need to have one team responsible for example, the quality assessment, or one team for the structural analysis, one team, like different departments like that. And of course, at some point, all those departments will need to work together and to share some information. The thing is that due to sometimes political aspects or just IP aspects, they don't want to share all the knowledge, all the methods, but still need to share some results. So how to tackle this collaboration in big companies and not to lose the expertise that is created? It can be, by the way, applied to only one single team where you have one expert, for example, who is used to create a lot of simulations. Then what if this powerful guy is leaving the company? Will you need to find someone as experienced, or will you keep the ownership of his knowledge? This is another question. And on top of that, the last point is the need for manual exploration of design alternatives. At the moment, with the current environment, if you want to study for another conceptual stage or another design, you will need to manually try new alternatives. This means also to manually deal with the fragmented workflows, this manual data management, and the fact that you have no collaboration. So again, it's a high increase in design time. So what we propose today, it's a simulation environment that will answer those questions. in order to reduce the design time and to faster the time to market, with the ability to automate the engineering simulation, the simulation process, and to put on top some strong algorithms to lead to better design alternatives and even some optimization phases. So this is what P7 Enterprise is made for. This collaborative engineering platform is deployed in cloud. So just to be precise here, when we say in cloud, it's not a SaaS, meaning that we at P7 do not operate the platform for our customers. We just sell it as is, and the customer are free to deploy it wherever they want. So it can be on premises to be totally detached from any outside network, or it can be on private clouds or even public clouds if you want. So regarding the confidentiality, this is totally fine. And this platform allows several topics, of course. First one is the collaboration aspect. So through a collaborative cloud environment, you may break down those silos between teams and allow those cross-teams workflow to be authored in real-time collaboration. So meaning that you can have different types of users all connected to the same platform. They can all work in their own environment, in their own profile, and at some point decide or not to share some of their work. They can share in different levels of rights, so they can also share only some results, but not how they produced the results. They can share everything, so you have the control on that. Second aspect is the productivity gain through a seamless integration. So the idea of that platform is to build those kind of objects that we call workflows. And a workflow is made of different blocks, so it's a blockchain. Those blocks are coming from a centralized but customizable block library. And every block is responsible for one single action. Those blocks can be also interfaces with your existing CAD, CAE, PLM, SPDM tools, in-house tools, whatever you want, just to reproduce your environment on the platform. You have also resource management at scale to call, for example, HPC or other cloud infrastructures from those blocks. Once you have created that kind of workflow that is representing your daily activities, you may also share it as a user web application to get more democratization in your company. So this way you can create and deploy those web apps to enable non-experienced people to use those engineering applications. Just in a few clicks with a very simplified interface, so other population of users will access the simulation capability without the need to understand deeply all the details. They have something already prepared and they just have to execute it to produce new results. And the final part is, sorry, I will close that and that as well. The final part is the access to best results. Like I told you, the company started with the creation of strong optimization and machine learning algorithms, which are now industry-proven algorithms at the time where Airbus was still in the loop. We kept the ownership of those methods, and they are then included directly inside the platform. If you want to use other tools, we are totally open, but those strong methods are offered to you. On top of that, we have an automatic selection and tuning algorithm, which is called Smart Selection. So it will help the non-experienced people into algorithm to still use them in the most efficient way. So it will help you to select what is the best technique to answer your configuration and also tune it at runtime in order to faster the results production. So this platform is a low-code automation, or made to be a low-code automation. It includes a very powerful workflow engine. So this workflow creation enables a visual representation of your executable process. So the idea is really to take what you already have in your company. What are the repetitive steps that you need to automate to be more efficient, and just to put that inside the platform. We don't want you to change anything, but just to reproduce in order to speed up your processes. You have this concept also of multi-level nested workflows, meaning that inside one root workflow like we have here, you may have one block that is in fact including another sub workflow. Okay, and same here, this blue block, for example, is including a third level workflow. And you can have an infinite number of layers like that. So you can start with very basic workflows, like just automating some very few steps, and then growing your methods like that step by step. All those blocks that you see here that are used to build the workflows, they come from a centralized and customizable block library, meaning that we share with you first what we already have produced, so some very basic blocks. And then if something is missing, if, for example, you want to connect with a software we do not have yet in the library, we have templates to help you connecting your own software, whether it's commercial or in-house, in order to reproduce exactly your simulation environment. Inside this environment, you have several roles, and this enables also this collaborative work in the cloud, including on-premises with different levels of rights. Finally, with those roles, you can have workflow sharing. So you may decide at some point that your method is well established and that you want to share it. You can share it with the IP, meaning that your colleague with whom you share it can be a co-author of that workflow. So it will be able to change it with you at the same time, a bit like Google Drive, you will see after. Or you can still keep the ownership, meaning that your colleague will be able to use that workflow to send new inputs and gather new outputs, but not to change what is inside. So you see, you have different levels of rights like that, allowing this workflow sharing. The final idea of that story is to accelerate the development cycle and to share the knowledge inside your company. We also have this resource management aspect, which is something that is often forgot by the company. All this IT infrastructure topic. In such a case, it's very easy because at the deployment time, so when we install P7 Enterprise, we start with declaring what are the resources available at your company. For example, if you're doing a lot of CFD analysis, we will say, okay, to do those CFD analysis, we have some specific HPC cluster available, and we declare that to P7 Enterprise. It will allow then that when, for example, a group of users is creating a workflow like this one, okay, every workflow is made of different blocks, and for every block, you may decide on which part, so on which resource you want it to be executed at runtime. Okay, so you have the same idea for more complex workflows or very basic ones. Every block that you see here can be allocated to a very specific machine. It's not dependent on the OS, it's not dependent on what type of machine. You can declare anything you have, even laptops, or we can think of tablets, for example. That can be the case as well. So you have management of the resource like that. And at runtime, P7 will also check for the availability of the resources. So every time a user wants to execute a new simulation, P7 will smartly check for the availability of everything that is needed to complete this job. If a resource is missing because it is taken for another job at the moment, it will just put the workflow execution in the queue and wait until this resource is available again. So you have a smart management and a smart schedule of those resources as well. It enables reliable campaign planning and the scalability, which is very important when you have this collaborative aspect. Last but not least, this engineering calculators I briefly introduced to capture standard tasks. So once a once a workflow is ready, so you have declared your simulation process in such a block diagram. This workflow has global inputs and global outputs that are there. And in just a few clicks, B7 Enterprise allow you to create very basic interfaces like this one. So you have here a small app which hides the complexity of the workflow and just shows you what you need to change in order to get new results. So you have here one column with the parameters, which are the inputs of the workflow, and one column with the results for the outputs of that workflow. So you may just change the few parameters, press play, and then produce new results like that. This interface is a web interface. It can integrate also SPDM, for example. It is connectable with REST API, so you can use it as a service. And of course, we produce this kind of interface by default, but it can be then customized if you want to have some report capabilities, for example, or to bring more context information. This is just basic HTML, CSS construction, so really easy to customize. And this allows to bring formalized simulations without any involvement of advanced users to a larger engineering population. So now let's go back to our core topic of today. So this multidisciplinary workflow for the suspension analysis of my car. So in that case, we had the involvement of different teams. The first one was the multi-body dynamics team, team of experts in MSc Adams software. So this team requires the suspension parameters, driving scenario, and road profiles in order to complete the simulation and to output the loads and kinematics. On the other hand, we had a second team responsible for the stress and fatigue analysis. Those guys are very familiar with ANSYS Workbench simulation. So to complete their job, they need the suspension finite element model, the load cases, the post-processing, and they can provide stress and fatigue results. Finally, the last one is the driver comfort team. So those guys using MATLAB a lot. They were relying on the kinematics, in-house methods coded in MATLAB, some requirements in order to provide the driving comfort. So the idea with B7 was to allow communication between all those teams inside one single workflow. So in the end, the workflow just like this. I will explain to you all the details. But basically, when using such a workflow, you have to input here as a user the road profiles, the driving scenario, and suspension parameters. Press play to execute it, and you will recover in the end safety factors, the details of each simulations, and a ready report. Okay, and this workflow just contains like that 3 blocks. So MBD, axle beam, seat suspension. But in fact, those blocks are hiding sub-workflows in the back. So we will see what is inside those boxes. And we just had one project team leader who was responsible for connecting those blocks together and ensuring that the data format is consistent in order to provide this ready-to-run collaborative workflow. So now let's see what's inside each of the boxes, starting with the multi-body dynamics. So inside this MBD block, we have actually this kind of workflow. So you see it's not so complex, just 3 blocks, but we will see that it faster a lot the simulation process because all the manual changes are automated here. So like we saw, the inputs for that block is the road profile, driving scenario, and suspension parameters. So the road profile is just definition of this kind of road here. So for that example, we have one obstacle. This is the definition of the road profile with quite flat road and straight. But we can imagine having some turns, for example, having different obstacles, having some climbs. This is the road profile. Driving scenario is the same with the speed, for example. So how do you drive the car, at which speed, and so on. And the suspension parameter, they are defined here. So this is the rebound and compression coefficients. Just by putting that, P7 now will automate the change of the simulation parameters with that first block. So through text parsing, we will just take the new parameters given by the user and build the script to solve the new problem. So in that script, we declare the road profile file, we declare the driving scenario, so the speed, the suspension parameter details, and so on, in order to prepare the script to be executed in MSc Adams. And this is exactly the second step. So to use the script that was prepared here to solve the Adams simulation. And finally, we have a post-processing of this same software. So now a different script to post-process the simulation that was just created. And this post-process now gives us the outputs as the cabin kinematics, the forces on the suspension parts, and the plots. You have here an example of plot that was produced by such a workflow. So here we have an Adams car embedded example with specific inputs and given outputs for that specific team. And this workflow is very low code, meaning that we have here Adams car experts that were just using the connectors with the text parsing and the Adams car to just embed their simulation. They had to embed one template, let's say, of simulation, and then just by changing the inputs here, P7 is able to adapt the new configuration and to run, execute new simulations to produce new results. The second workflow was related to the stress and fatigue team. So now using ANSYS Workbench and some in-house scripts, it takes as inputs the loads from Adams, so from the previous team, driving scenario, same as before, and the axle geometry embedded. So we have a geometry definition. It will start, same as before, by defining some parameters. So to read the loads that were produced by Adams on the first block here. Then to make some approximations just to ensure that the loads are well prepared for the ANSYS Workbench simulation. So just a change in the data format here. So you see no more manual data management. Everything is done with little scripts. And then execute the ANSYS Workbench block. So again here, nothing was hard-coded. The block was already prepared, so the users just had to plug the existing simulation, the existing geometry and so on, into the ANSYS Workbench block, and then each simulation is automated. On the other branch here, we had to read the trajectory of the car, so this driving scenario, just to prepare then the fatigue analysis. So we have in results the fatigue of that specific part, depending on the driving scenario. And the outputs are the damage value and some plots. You have, for example, those two plots here, where you can compare, for example, the number of cycles with the damage value, just to check at which number of cycles you can go until you reach the damage limit as per the requirements, for example. So this is very easy to see on that kind of curve. Here again, this idea of low-code automation, all right. The fatigue script that was provided here has already been created by the company before we integrated it inside P7. So just a few adjustments, but nothing was really hard-coded or redeployed to be integrated inside P7 Enterprise. We just captured what was already existing. And the last workflow is this one. So now on the topic of driver seat suspension and driver comfort using the MATLAB tool. So this workflow takes as inputs the cabin kinematics. It will just same as before, prepare the kinematics format to be executed in the MATLAB script. At that point, we do not have the pure MATLAB block, so we are using the open source version of Octave. Okay, and inside Octave, we execute the MATLAB script. So we have this kind of schema here that is representing exactly the system included inside MATLAB. So you see several springs. We have actually one spring here, which is connected between the ground and the car, basically. So it includes the car and the seat. And then we have on top here a box representing the driver. Okay, so he's seated on two different springs. So this kind of model is included into the MATLAB script, and it will provide then the acceleration root mean square, vibration dose value, and some plots, like for example this plot here for the acceleration in Z. And through those results, then one can compare or check if the provided configuration can deal with the driver comfort requirements, for example. Through those workflows, so through this one with those three blocks, so the multidisciplinary workflow, we can then expand it to a variety of other scenarios with one single tool. So we have P7 Enterprise in the middle with this fully automated workflow, scalable execution in the cloud, version control, one link to the optimizer. So you can go directly from that multidisciplinary workflow to an optimization. We can think, for example, of virtual testing. So imagine you have a collection of different road profiles and driving scenarios for given suspension parameters. You can have some loops or just input your road profiles and driving scenarios to perform hundreds of simulation over those scenarios in an automated manner and generating the reports for each one of them. So instead of having real-life testing, which is very expensive, you can have virtual testing. By the way, you can launch several executions in parallel. So at the moment where you do not have any more resources, your execution will be queued. So you can launch, for example, all your execution on Friday evening and get back on Monday morning, check for the results. Because it's cloud infrastructure, it will work normally. Second scenario is the design validation. So now imagine that you have various suspension types or parameters for one given scenario. You want to check for this suspension design. So you may try several configurations and confirm your decisions with all the required checks without the assistance for domain simulation experts. Okay, just by executing this workflow that was prepared for you, you can send new suspension types, new suspension parameters, and check for the results. You do not need anymore to master Adams, ANSYS Workbench, MATLAB, just need to execute the workflow. And the last idea that we had is the design optimization. So having a range of parameters, for example, on your suspension types and constraints for safety factors, you can obtain the best design alternatives automatically, still coping with your constraints and requirements. So by using P7 optimization algorithms, you can declare your optimization task and it will work for you using this multidisciplinary workflow to guide you to the best design. So in the end, with P7 here, we considered three main topics. The first one was the multi-body dynamic simulation for multiple predefined driving scenarios. So this first workflow. The second workflow was about stress and fatigue calculation. And the last one about driver comfort assessment. With those considerations, we explored how to assemble complex simulation workflows, including tools like ANSYS Workbench, MSc Adams, MATLAB, and Python scripts. And in the end, we established collaborative work, all of that in the cloud. So this topic enabled various exploration and testing scenarios for a complete multidisciplinary model in the cloud. And if I may have time, so this ends up my presentation with the slides, but I would like just to have a quick tour of the platform here, just to show you in maybe 5 minutes how we can work with it on the platform. So you see here, I am connected directly on the web because I'm on a private cloud. So my deployment is P7 online, and I can go to this car suspension demo where I have several workflows here. So this is my project explorer, let's say, and I can open from there, for example, the multi-body dynamics workflow. Okay, so now you see those 3 blocks I told you. They are coming from this library here. Okay, so I have a library of different components, and from the library I can just drag and drop my blocks to create my workflow. I will just show you some small details here, but for the script modification, I told you that we have to first change some path and some parameters in order to recreate a new script for Adams. So this is exactly what is this block doing. So taking the comments initially created, it will have some operations of text parsing to replace new variables values. So if I press play here to have a test, I see that on this line, I have, for example, this part of the comment that will be replaced with the name of the new file for the road profile. Okay, so this is an example. And on top, I think we have the values. So here again, we'll replace the road profile. And here you see the scale factor for the compression and same for the rebound. So those are the suspension parameters. Once this script is prepared with the new parameters, it is then used to the solver here. So you see this Adams solver.cmd. This is exactly the file that was modified here. And then we use another script, so Adams post.cmd, to have the post-processing activity. Okay, I can check now from the platform the runs here. So I have one execution, and inside that execution, you see my blocks were executed, and I have a lot of files that were produced. So for example, I have my cabin kinematics in the form of a text file. So here I have all my results of the cabin kinematics. So here it's also a way to capitalize on what was produced. I can see different runs, different executions, and still keep all the files in the same location. So this was the first workflow. We have the same for the axle beam. So using ANSYS Workbench, this is it. For ANSYS Workbench, we have a very nice interface over there. So this block, like I told you, it's low code. So it enables anyone to just plug an ANSYS Workbench model and to extract the parameters coming from that model. Sorry, this block was not used for a while. So it may take a few to open. But anyway, the idea here is to open this block. Here it is. And you see, to load here my ANSYS Workbench projects, it will by default extract all the parameters that were defined on ANSYS. So then I can work, I can change or extract the values of the available parameters. And this is exactly what we connect. Then here, for example, the loads are given by the Python script block. Just to show you what we have then on the seat suspension. This is also another kind of block here for Octave. This one is even more interactive because you can directly put your MATLAB script on the block. Okay, so you see here you have a direct view of that script, and you can even test it. So by giving some inputs, you can click on the run code here, and you will have a live execution of that code. So you can even debug somehow your script. And the script will be executed at runtime to solve this workflow. And then here comes the end. It's the multidisciplinary analysis. So there you go. You see those workflow reference. So it's a dynamic link to the blocks, to the workflow I just presented to you. This MBD, seat suspension, and axle beam. And in the end, once everything is prepared and executed, I have a little script to prepare a report and to execute Microsoft Word in order to prepare a .docx report automatically. So I can show you that, by the way, I have in the runs. So you see here different kind of road profiles. And for that road profile, I have run report docx that was prepared. And if I download it, here it is. I can open directly the report and check for the results of that simulation. Here we go. So we have the name of the author, when was the report created, what is the road profile, the velocity, and you have all the results with all the plots that is automatically available. So there you see, even if you're not familiar with all the simulation tools, even if you are, for example, a project manager, you can still have access to very precise and detailed simulations, detailed results, without overloading your engineering team. So you can really leverage from your team capabilities. And then you can go even further, having, for example, a design of experiments workflow here involving this multidisciplinary workflow. So if I want to open that, this is exactly the workflow I showed you just before. So it's a dynamic link again, but now it's not anymore the user who is changing the inputs. This is the block design space exploration in order to look for you what is the best configuration for your road profile, for example, or your axle beam geometry. In the end, going from the studio here where all the experts are working, we can move to what we call the apps hub. So exactly where we have this collection of apps. Okay, here we are. So just clicking inside my workflow, just in a few clicks, I can provide applications like that. For example, this kind of application has been customized. I can briefly show you. So this is not anymore on the car subject, but here you have a full description of the task. I don't want to go into details today. And you have description of what is the model we are using now, some of the inputs to give to the simulation, how to set up your optimization. And in the end, you have the report, which is directly displayed to the user on the app interface with different plots, even interactive plots. Here you can work directly from the cloud platform. And this ends up my presentation. I hope I was not too long. So if you have any question or comments, feel free.
Hello, Nina. Thanks for the presentation. I think we have one question now. You can reach the chat section, I guess. If you want, you can read it silently and answer it if you want.
Right. So I'm not sure I.
Uh,
Okay. Have you had any experience with
yeah,
MSc Apex,
that one.
mass run automation? Yes, we do have MSc Apex. We are, by the way, building a block at the moment I'm talking to you. Nastran as well, we have some examples, maybe not native block, but for sure we can integrate via P7 for complex CAD. Yes, with different dimension values. So as long as the model is parametric, then it does not matter what kind of dimensions we have. We can still adapt. The only requirements is to have a parametric model that we can play with, and of course to establish the connection with the required tools. But here, MSC, Apex, and Nastran, this is totally fine. And then you're saying the loop could be such as update thickness, yes, add a rib or remove a rib, change other 7-8 more dimensions around the CAD, yeah, mesh the modified CAD, exactly, create DOE based on those design dimensions. Let's assume that's geometry. Yeah, so I see that you already have in mind some complex workflow, or not complex, but precise, let's say. But indeed, we can have a workflow like that with different tools, like one for, I can show you, by the way, how we have many different applications, but for example, we have this one. So here you see we start the workflow here on top. So it's a multidisciplinary analysis, but made by one guy. So we are starting here with NX geometry update. So like you're suggesting, you change here the CAD model. Then once the CAD model is changed, it will be directly sent to the ANSYS workbench. So of course here we can replace those boxes with your preferred tools. So it can be Apex and then Nastran. And then just having this interconnection, you see that now ANSYS, same as OpenFOAM and another surrogate model, they are then connected to a design space exploration. So this block is responsible to drive the design of experiment. So based on the variables you're giving to the block, it will understand under which boundaries it can drive the design of experiments, and it will automatically send new values to ANSYS, or it can be sent to NX if you want to update the CAD model, and then re-execute your chain automatically in order to produce new results. Then you can have this collection of new points that is created, and we can think of many different other topics. For example, to go now from the results of the DOE and to send everything to a surrogate model to train another model, and then use that model instead of the heavy simulations, for example. So this is what you're proposing is sounds very familiar to me, and yeah, for sure we can try something like that. Yeah. So thank you for that question.
Thank you for that detailed answer, Nina.
No worries. If I can.
Yeah. If your presentation is over, I think we can finish the webinar.
All right.
Thank you so much for the presentation, Nina.
Thank you, everyone.
Değerli katılımcılarımız, daha sonradan aklınıza gelebilecek olan tüm sorularınızı destek@bias.com.tr adresine mail atarak iletebilirsiniz. Katılımlarınız için teşekkür eder. Herkese iyi günler dilerim.